Now light is incident. This is the work function, and we have a battery here. This will be ejected photoelectrons. This is the work function of the emitter. No. So shall we call this is the emitter? This is a collector which will collect it. And this is cell, this one. So what is the equation for Kmax? So Kmax, we write like this, no? Kmax is equal to Sc by lambda minus work function. Then I'll increase the potential of cell. Then at one potential, so here so I should make this positive, no? Now at one particular specific potential, what will happen to this maximum kinetic energy electron? It fails to reach the collector, and that is called as the stopping potential. And we know EVS should be equal to Kmax here. So I'll write it Sc by lambda minus work function. Already we have discussed. Okay, let me plot this graph. Kmax, so let me plot the graph. There's one very basic fundamental graph is there. So when I plot the graph, so what is the graph here? Graph will be stopping potential versus the frequency of radiation, or 1 by lambda. Anything you can take it. So how the graph will be? It's a graph stopping potential Vs, and if you want you can write frequency or 1 by lambda. HF minus this one. So let me take the frequency. In NCERT book, he has plotted against the frequency. In SURMA, he has plotted with wavelength. Both are 1 by lambda he has plotted. Here I took that one. So we can write C by lambda is F, no? So HF by E, that one. Now, how the curve will be? So when I plot the curve, no, for different metals, what happen? The curve will be like this. But all the metals, what happen? This angle should be same. Any reason for that? Some alpha, I'll write it. Again, you'll get confused with this. These angles will be same or should be different. There's a metal 1. The slope is telling must be same. There's a metal 3. And when I take this intercept, okay, I'll show till here. Look at this intercept. So what do this intercept should be equal to? Phi E, no? Here 1 E will be there. So this should be phi 1 by E. So there's an interpretation of this graph here. So this particular curve, so for all the metals, the slope must be same. Will you agree? So what do that slope indicates? H by E, and H is it's a constant, E is a constant. So there's a one advantage for us. So if I plot the graph, I'll do the experiment, and if I get different slopes, so some problem is there with the experiment. And if I produce back this straight line, and y-intercept, that will become work function by E. So like that, I'll find out the work function of different metals. So I can Where is the frequency of incident light? Stopping potential, what is there in that one? I'll take a cell. I'll note down that one. So from this what happen, I can calculate the work function of different metals. So for different materials, the work function will be different here. So that's what this particular, the interpretation of this graph is. So this slopes must be same. So what is that tan alpha? Tan alpha should be equal to h by e. Or if you plot 1 by lambda, then it should be hc by e. Any good questions can be asked with this information. Now look at this metal 1, metal 3. Which is having more work function? Metal 3, no? That's what's like this y-axis. Y-axis, so therefore metal 3 will have more work function than metal 2 than metal 1. So this particular basic and work function is a very difficult quantity to measure, and from this experimental graph I'm able to predict even the work function also. Already in mains they asked one